Oh, I'm sorry. I'm sorry.
Wow, I was wondering what was going on. Glad everything's okay.
My mom on she switched on the mixer grinder and something.
I understand. Okay, so let me go through some of the attendance here. Let's get started a little bit. We have a number of people on. Sharon, you're clearly on, so I'll mark you in. Hunter is on, and he's a good man. He keeps us straight. Do you have your hat on today, Hunter? Go ahead. Wow, there you go. Indira, what do you do? That's like a talk show host. Indira, how are you doing?
I'm doing good, thank you. And how about you?
I think I'm all right considering this is a Monday. Oh, wait, it's not Monday. It's okay. Nikki. Nikki,
here.
Are we doing good, Nikki?
We are lovely. How are you?
Good. Joshua?
I'm here.
Okay. We missed you for a while, Joshua.
Yeah, sorry, I had to work.
We know the fish are biting, but we still need you to come. Monica Hickson. Monica, I thought you were around. Earth to Monica. No Monica. Okay, Reba. Calzada.
I'm here.
Are you doing okay?
Yeah. How are you?
Okay. Reba Colson.
Yes.
You're here. Good deal.
I'm here too. Rebecca.
No, Rebecca, you're not here, are you?
Yes, I'm there. I'm here.
I know you are. How about Rosio?
I'm here. Good evening, Dr. Wick.
So do you still have 3 children and a husband? I guess that was a tough question. All right, Rosio.
Yeah, I still have 3 children and a husband, and now I've gone from 3 dogs to 5. How about that?
Oh my gosh. Ah, Ryan, are you around?
Yes, I'm here.
I gotcha. Is there anybody here that I missed? I think I got everybody so far. Monica Hickson. I did call you, but I think you weren't here.
I didn't have audio.
Okay, Monica, that's good. Who else? Amanda. Let me look at Amanda, see what I can figure out. Amanda, are you doing good?
Yes, I am. Thank you. How about you?
I think so. A friend of mine just got a job at a place called Best Buy. Ever hear of it?
Yep. Only once or twice.
She's pretty excited about it. Vanessa, are you here? Vanessa, I think she's here. I got a hand signal that she is. Did I call you Ryan?
Yes, you called me.
I got you. Did anybody I miss so far? Holly, are you here?
I'm here.
Been shopping lately?
Yeah.
Yeah, I
Mhm.
went shopping too. I kind of shop when I have money coming in or something, so it's not good for me. All right, so who you all know I've got to do a report card on you guys. You all know that? I'm supposed to do that like tonight. So if you're really nice to me tonight, then I'll remember that and make. Wait a second, is that my doorbell? Oh, somebody's delivering me pizza. Oh, the pizza. It's from Sharon. Oh, Sharon, you're gonna get some. No, I'm just kidding. So anyway, I do have to do a report card on you guys, and I'll look at your stuff here. How many pluses you might have? How many negatives? No, nobody has any negatives. But I usually write something good about everybody. So let me look at one other thing here. Nikki, are you still there?
I
Miss Anderson?
am. She is.
Man, I want to just say I am extremely, unbelievably satisfied and happy about your situation. You know what I'm talking about, right?
Yes. And I have to thank Edith and Amanda for their help. So it was a team effort, and I appreciate everybody.
Edith and Amanda. Edith. I know it's Amanda. Amanda, you didn't tell me you did anything, did you, or did you?
No, I didn't tell you I helped her, but thank you, Nikki, for the shout out. I did help her.
All right. And so I made a note of that. Who about Edith? Who?
Edith Navarro?
I'm
She
here.
just joined.
Let's see.
They both were great. And thank you for helping as well.
I don't have her in this course. I'm just kidding you. Edith, I appreciate that.
You
I got you. So you are here tonight.
Yes,
You're
I'm here. Yes, sir.
All right, you got to make sure I know that. Is Dylan around? No, Dylan. How about Joshua? Did I call you? Yeah, Joshua, you're here. Erica Whitehead, are you here? All right. Well, somebody here, if you can be on the lookout, if anybody comes in, that's good. Tonight is a unique night for the class. It's we're gonna do. I already have it here. Stuff on logarithms, and it's called exponential and logarithm equations. And I want to show you how to do these. And it's like Greek to you guys. It'll be like Greek, except for when I explain it. You will understand it, I think. Think you will. Yeah, of course you will. And if you don't, you need to raise your hand. So I've already got it pulled up. Man, maybe I'm way ahead of you here. I went through the whole chapter a couple times, so you can see it. We're actually on 4.4 for your record books. And there it is. Now, that's me in the front there, jet skiing around. I don't know the lady in the back. She just happened to be there and she hopped on. No, I'm just kidding. All right. if I have something like this, I don't know if we can do this one even. I'm assuming we can. To solve a problem like this, most of the time, we have to use some rules of either logarithms, log natural. But the rule is, if the bases are the same, you can solve for the top. Well, the base on the left is obviously 2. If we can make the base on the right 2, it's now 2 to the 3rd power times the 3 was there. Did everybody see what happened? I changed this 8 here to 2 to the 3rd power because 2 times 2 times 2 is 8. Does that make sense to anybody up there?
So it's 2 to the 3rd of the 3rd power?
It's 2 to the 3rd times the 3 that's up there.
Okay, yeah.
We just changed the 2 so that the bases are the same. These are the same. Now, if they're the same, the rule is then x will equal 3 times 3, or x will then equal 9. And that should be true. It's amazing I made this problem up. So if you put 2 to the 9 power, it should equal 8 to the 3rd power. Can anybody use their calculator? I'll do 2 to the 9. Let's see what we get. 2 to the 9th power. I get 512. That's over here. And what's 8 to the 3rd power?
It's 512.
512.
Isn't that amazing? I just did that off the top of my head. It's pretty good. That's great. But that's the deal. I got lucky. Every now and then I'll get lucky. I mean, it's crazy that this worked out. So, but I hope you understand. So now let's go back. It was funny to me because my luck today is pretty good. Pretty good today. So look at A. A has 2 to the 3x minus 8. On the other side, it's 16. But they changed the 16 to 2 to the 4th power. If you look at the second line under A solution, now once the bases are the same, you can get rid of them, and then the exponents become the same. So you have 3x minus 8 equals 4. You push the 8 to the other side. 3x equals 12. Now x equals 4. Isn't that pretty cool? That's how you solve that. One way. Is anybody with me on that?
Yes.
Good. At least I got one amen. If you don't, man, just to say, Dr. Wick, I just don't get it yet. But 16 is 2 to the 4th power. Now, look at B. If you look up there, you can see I have a 27 and 9. So it's going to be 3 to the 3rd power times x plus 3. The other one's going to be 3 to the 2nd power times x minus 1. Now, the x plus 3 will be in parentheses, and so will the x minus 1. So you don't have to worry yourself about that. It's in parentheses. And there you see it in B. Right there, the second line. Well, third line, they put it in parentheses. They put it in parentheses the reverse way. On the third line, they get it right. Now, on the third line, since the bases are the same, now you have 3 times x plus 3 equals 2 times x minus 1. Now you have 3x plus 9 equals 2x minus 2. You want to get x by itself, keep it positive, x equals negative 11. And that's the solution. I went into pretty big detail here in number 1 because I think it's important to understand that. Are there questions about the one in front of you from anyone? Are we good?
Yes.
Yeah, I'm good.
Yes. Yes, sir.
Very good. All right, so we're going to move on now. It's going to get a little more complicated. Now, A is going to be different from B. But look at A. A has 4 to the x equals 15. Now, if we use log natural or logs, we can solve these. Let me show you. So 4 to the x, if we use log natural on the left, remember, whatever you do to the left, you got to do the what? To the right. Whatever you do to the top, you have to do the bottom. Are we still okay with that so far?
Yeah, I understand it.
Okay, now we're going to use the power rule. The x goes in front, and it's still the same thing. So now you have x ln4 equals ln15. Now, if you divide the left-hand side by ln4, you get x by itself. But if you divide the left by ln4, then you got to divide the right by ln4. So I know you most of probably have this, but I'm going to, this is important now. So I want to make sure, well, it's all important, but I want to make sure you get this. Okay, so we said you have x ln 4 equals ln 15. And all we did is we added ln to the left, added to the right. Now, if we divide this side by ln 4, it becomes 1 and you're left with just x. But whatever you do left, you got to do the right. So the answer is going to be ln 15 over ln 4. Let's see what that looks like in the calculator. So we should have the calculator there now. We said we'd have, so you're going to start with parentheses, at least in my calculator. We're going to put in the ln 4, close parentheses twice, that will match everything there, and divide it by ln 15. You don't need parentheses in the bottom. Probably don't need it on yours for the top either. My bad. When you divide the left by ln 4, you got to divide the right by ln 4. Let me start over. Parentheses. So we had ln 15 on the top. Boom, boom. Divided by ln 4. Close our one parenthesis there, hit enter, and you get 1.953. I'm hoping that's the same as the book. And you get 0.195, and they give it approximately. So that's pretty good. Now, there we used ln. Now, you could use log too. So if you take log on the left, look at B. It's in red right there. If you do the log on the left, you got to do the log on the right. Now, the log and base 10 cancel. It gives you x. So the answer is log 120,000, which is approximately 5.08. And you just have to put that in your calculator. You don't have to do anything more in terms of your calculation. Just have to put in log 120,000. So let's again take a look at that. Here's our log right here. So we're going to do 120,000 close it with a parentheses and hit enter. And there you get the answer, 5.079. Now, you can't do these problems if you don't know how to use your calculator. But wait, did we get the right answer? 5.0. Yeah, then we'll 5.08. We put 5.079. Ours is more accurate. It's okay. Now, so are we still all okay so far up to example 2?
Yeah, I'm good.
I'm good.
All right, I just want to hear a few folks. Now,
I'm
let's
good.
look at it. Thank you, Sharon. Let's look at Sharon. Let's look at example 3. Our goal is always to get x by itself. So you can see the x is an exponent. So we know, generally speaking, we're going to have to use ln and we're going to have to use logs. But we can get rid of our -3 by adding it to both sides. So now we have 40e Euler to the 0.6x will equal 240. There it is. You can see it's a second line. Why? Because I added 3 to both sides. Then they divide both sides by 40, which gives you e to the 0.6x equals 6. Now, you don't need the 0 in front of the point, but they have it there. Now, the rule is if you add ln to the left and you have an Euler, it becomes 1. Actually, it does become 1, and the power rule brings the 0.6x up forward. So think of it like this. L and E are 10 over 10. They cancel. But before you canceled it, you put 0.6x up front using the power rule. Now, to get x by itself, you have to put in ln 6, and you have to divide by 0.6 to get 2.99. Now, I'm going to take a little break here and get a drink. I want to get an amen from everybody that you can put in your calculator ln 6 divided by 0.6 and get me this 2.99. I want to do that because today I did it in class. Everybody said, Dr. Wick, I got it. And out of the class, about 33 people, at least 7 or 8 didn't have it. They didn't know how to do it. And I go, why? Well, Dr. Wick, we didn't want to bother the class. I'll be right back. So please do it. And I'll probably ask you guys if you got it. Are you guys okay with that? Can anybody hear me?
Yes.
Yes.
So you're going to do it? Okay. All right. Did anybody not get it and need help?
I got 2.30.
You got 2 point what?
30.
You did something wrong.
What
So-
did I do?
Hmm?
I said, what did I do wrong?
Well, let's take a look. You got your calculator there?
Yes.
Okay, so here's what we're going to do. Going to go to my calculator. Rebecca, you ready?
Mm-hmm.
Getting a lot of feedback from you. Okay, so here's my calculator. It's on. It's clear. ln is this one right here. And I'm going to put 6, and I'm going to close my parenthesis. And I'm going to divide it by, that's this sign right here, 0.6. Is that everything you did for sure?
Yes.
I didn't close my parentheses.
Oh. Does that help now?
Can you do the first part again?
ln, just hit ln.
Yes, I got the same thing you did.
Well, so Rebecca, I'm going to give you a big minus sign. Tonight's grade night, and I'm just so sorry, but you got, no, I'm just kidding.
Please,
You're going to
it
get a
took me
plus.
days to
I'm
update
going to
this.
give you I'm going to give you a plus because you spoke up. That's good. Thank you.
Thank you.
Yes. So anyway, ln, use parenthesis, put in the 6, close my parenthesis, and simply divide it by, boom, 0.6. And hit enter. Can't make a mistake. Now let's do this. Let's say you hit log 6, close parentheses, divided by 0.6. You would get a different answer in this case. Or would you? Let's see.
You forget
I know.
divided side.
Yeah, there's no division sign. It didn't stick. Watch this. Now it's different. Now, normally, depending on the problem, you could get them to be the same, but not in this case. So, anyway,
God bless you.
thank you. I need that. All right. So, back to the book. And we'll go to number 4. Now, in number 4, they push, excuse me again, they push the 5 to the x minus 2 up front. Let's look really close at this problem. They added ln first, and then ln's, let me see if this is the best thing to do. Some better note taker here. Let me do this. The book has it, but I want to do it slowly this time. I won't always do it like this. I'll use the book because I know my writing is just beautiful. Sharon, could you put your hand down? Because it's coming across all the time. That'd be good if you can. Thank you. Okay, so look. They give us the problem 5 to the x minus 2 equals 4 to the 2x plus 3. Now, the issue is we want to solve for x, but this is in the exponent. So if we take log natural of the left, we can take it of the right. Now, when we do that, the x minus 2 goes out front using the power rule. Edith left it said. So this just moves up front. Whatever you do to the left, you do to the right. So you have, in parentheses, 2x plus 3. And then you have your L. Pardon me?
ln4.
Yes. So everybody see what happened there? I added ln in the left. I added ln in front. Then you can use the power rule and push it up front. Now, I'm not going to erase it. I'm just going to go back to the book now again. Page 507. So right below the blue bubble, you see you have x minus 2, ln 5, and then the 2x plus 3, ln 4. Now, the reason why I showed it to you is because the next step is sometimes students don't understand it or see it. But they use the distribution property. Let's see. So what they did is they took this ln5 here and multiplied it by this and this, because that's the distribution property. So you have x times 2x plus 3, or excuse me, my bad. Gosh, I wish I could erase this. You have x times ln 5, and then you have minus 2 times ln 5 equals 2x times ln 4 plus 3 times ln 4. Again, this is times this, and this is times this. Now, I've kind of messed it up because it's pretty messy, but let's now go back to the book. So that's how they get the line right below the blue bubble. You have x ln 5 minus 2 ln 5. I put it in parentheses. You can, you don't have to. Then the next line, you have 2 ln 5. Or on the right-hand side, you have 2x ln 4 plus 3 ln 4. Let me move this. I want you to be sure you understand how the information above this blue line where it says, remember that, gets to the line right below it. I'm going to stop here and ask anybody if they have a question again how that happened. ln 5 multiplied everything to the left inside the parenthesis. That's how come you end up with x ln 5 minus 2 ln 5. On the left-hand side, it's 2x times ln 4 plus 3 times ln 4. We're just using the distribution property. Is everybody okay with that? Anybody okay with that? Anybody hear me?
Yes.
Yes.
You guys get it? Any of you all?
Sure.
Did anybody get it?
Yes, we got it.
I do.
Okay, now the next step, I'm going to write prettier this time. All right, so making my notes. Okay, so let me share with you the next step. prettier. So here's where we left off. We have x ln 5 minus 2x ln 4 equals 2 ln 5 plus 3 ln 4. Now, we want to get the x's together. So let's focus on this part right here, because the x's are on the left-hand side. I can factor out an x because it's in both these two parts. That would give me ln 5 minus 2 ln 4. I want to take a break there. Did you see how I factored the x out of there? There's an x in front of the minus sign, and there's an x behind the minus sign. I pulled it out, left the minus sign in, and left what was there. So ln 5 is there, and 2 ln 4 is there on the left. Everybody okay with that? Can anybody see that?
Yes.
The x came from here and here. And that left it inside. Now, the right-hand side stays the same. 2 ln 5 plus 3 ln 4. Now, this is easy. We'll put parentheses on this. If we divide this side by ln 5 minus 2 ln 4, parentheses, you get x by itself. But whatever you do left, you got to do the right. So ln 5 minus 2 ln 4. We have to put this part in our calculator because that's going to give us x. So you have 2 ln 5 plus 3 ln 4. Notice that's all in parentheses. Divided by ln 5 minus 2 ln 4. Now, let's take a break here on this. Let's go back to the book. So again, look what they have for the x. Now, they don't show you parentheses here, but for your calculator to do it, you have to have parentheses. So it says x equals the 2 ln 5 plus 3 ln 4 divided by ln 5 minus 2 ln 4. Let's put it in our calculator and see. I'd hope that's what you'd want to do to make sure what we're saying is true. Now, when I used to do this, students would not do well in this part. So if you put a parenthesis first, then your 2, then your ln. Now you have 2 open parentheses. Then you're going to put 5, close parenthesis, plus 3 ln 4, close parenthesis twice. You have 1, 2, 3 opens, and 1, 2, 3 close. And you're going to divide that by the bottom part, which is open parenthesis, ln 5, close parenthesis, minus, that's that, 2 ln 4, and close parenthesis twice. Yeah. Hit enter. Negative 6.342. Let's see if that's right. Look at that. negative 6.34, and we got 2. Isn't that pretty neat? You guys got it. So the practice that you need is where it says the solution set is, you got to learn to put all of this stuff here in your calculator and come up with negative 6.34. If you can't do that, you have homework for that. Any questions about that part? Nobody? We good?
Can you go back to your calculator? I think I put something in wrong because I got 4.64.
You have double parentheses and all that? Take a look.
Oh, I see what I did wrong. Thank you.
Do you? Do you?
Yeah, I put too many double parentheses.
I don't know if that would hurt, but maybe. Did you get the right answer then? It seemed to me that that wouldn't hurt much. Maybe. You want me to put it in the calculator again?
Yeah, you can. Thank you.
Okay, so let's do it again. Okay. Let's get out of that. This thing just wants to erase everything. Okay, there we go. So we're going to open parentheses first. We're going to do 2 ln, and then that's 5. Close our parenthesis here. Then plus 3 ln, and it's 4, and close our parentheses twice. Man, you good with that so far?
Yes.
Then we're going to hit the division sign. And then we're going to open parenthesis again. This time we're going to hit ln 5, close parenthesis once. Then minus, that's this thing right here, 2 ln 4, and close our parentheses twice. And hit enter.
Yep, I got it now.
Okay, it's good practice. It's good. Let's go to the next problem. Oh, well, I really wanted to do this. Before we do the next problem, I wanted to show it to you without you looking at the book. You have the Euler to the 2x minus 4 Euler to the x, I think plus 3. Now, they want you to factor this. Now, this is the same thing as if you have x minus 1 times x minus 3. It's the same thing, except for x's are the Eulers. So you have e to the x minus 1 times e to the x minus 3. It's the same thing as this one right here, except for you have to know when you take e to the x times e to the x, you get e to the 2x. That's what you have to know. Now, once you have this, it's pretty simple. Now, you have to set each of these up equal to 0. So you have e to the x minus 1 equals 0. So then you say e to the x equals 1. What does x have to be 1 for anything? Anything to the what power gives you 1? Does anybody know or remember?
I squared?
0. Anything to the 0 power is 1. 3 to the 0 power is 1. 6 to the 0 power is 1. And that's that one. Now, how do you get the next one? So you have, this is the problematic one. So you have e to the x equals 3. Now, how do you do that? Let's go to the book now. You use the same thing you've done before. Since the x is in the exponent area, you're going to use ln. If you have ln on the left, you have to have it on the right, as you can see. The ln and e cancel, so you now have x equals ln 3. We go to our calculator. We just write in ln 3. Put our parentheses, enter. What does that equal? 1.098?
Yes, 1.09861.
Yes, and let's see what our book says. Well, do they give it to you here? Oh, they say it's approximately 1.10. They really moved it up there, but that's good. So that's number 5. Number 6. Now, in logarithmic expressions, remember the bases stay the same. You get rid of the log and you change the exponents. So now, let's look at A. You get rid of the log part, leave the 4. 4 always stay the same. You switch the x plus 3 with the 2. So you have 4 squared equals x plus 3. You have 16 equals x plus 3. X equals 13. Now, there's one rule that I want you to be clear of. Look at rule number 4. Rule 4 says that your number must be greater than 0. That means your log number has to be not only, it has to be positive. It can't even be 0. There are no such thing as 0 logs. Now, in exponents, anything to the 0 is 1, power is 1. But in logs, they cannot be 0. So let's look at B. B starts out with the way the equation is written. They divide both sides by 3. They get ln 2x equals 4. Now, ln is the same as log e. Log base e equals 2x to 4. So just remember, ln is the same thing as log base e, and then you'll have the 2x on the left equals 4. Let's look at the next page. Oh, by the way, I hate that. I remember this problem in the book. Don't pay attention to line 3. That's why it says optional. I fell for that problem even in my practice today. And before I looked at the solution, I knew that it was a bad way to teach this. Let me show you this. Let me show you. I will make it 100 times easier. That problem is like terribly hard without it being made easy. So they give you this 3 ln to the 2x like this equals 12. Now, if we divide both sides by 3, we have ln to the 2x equals 12. Everybody see how, excuse me, gosh, equals 4.
Yeah, 12 by 3.
At 12 divided by 3 equals 4. Everybody see how that came about? Divided 3 by both sides. Everybody okay with that part so far? Now, let's go back to the book and reinforce it because I messed up in my writing, but you'll see it right here. You have ln 2x equals 4. Now, don't do the third line. Don't pay attention to it. Let's look at the next line. Next page. Here we go. It has e to the 4th equals 2x. Someone say, well, how in the world can you go from that to that? Let's go back. What is the base there? You have ln log base, they do log base e to the 2x equals 4. That's this. So what they did here, they wrote log base e because that's the same thing as ln to the 2x equals 4. All they did was take ln equals log base e as being the same. Now, we can change the rule. To get rid of the log, we simply say, keep the base the same and switch these two pieces of the puzzle. Log goes away because we're using the e. We're changing from log to exponential form. So you have e to the 4 equals 2x. So how do you get x by itself? Let me write it this way. 2x equals e to the 4th power. Somebody out there tell me, how do I get x by itself here? It's just too simple. How do you get x by itself? Come on.
You divide by 2.
Exactly. So e to the 4th, yeah, divided by 2 will equal your x. Now, let's go to the book and confirm all this. But you can see it. All the rules for math apply. You just have to remember what they are. And you will, because we'll have good reviews. We're going to the next page. I did all this because I wanted to see e to the 4 equals 2x divided by 2. Now, we got somewhere in here, they don't even give you the answer. The answer is supposed to be, I wrote it at 27.29907. I did all this earlier. Let's see if we get it right. We're going to do e to the 4 over 2. And we're supposed to get 27.29907. Again, let's see. I wrote all this down. I don't want to. So we're going to do here. Stop this. Go here. And it's amazing to keep all this stuff straight. But I did. Come on, turn on. Clear. So we're going to do E. Right here is E. We're going to do second. E. We're going to put 4 up there. Push it out. Divide it by I believe 2. And boom, 27.29907. Just exactly what I told you. Now, again, I don't know if the book does it. I don't think it does. But it should. And I don't think they even show you the answer. They just say you can check it. Now, there's one more problem I want to do for the day, because I know your brains are probably saying, and I try to keep you for a little over an hour is all. We're always about an hour. Let's see the problem. The next problem is just too easy. This is going to, do I have one problem or two? I got to do 2 problems. I'm going to do this one that you see here in front of you, 7. I'll skip that and then go to that. I got to do this one because it's the same thing as 8, except for we're going to use the quotient rule here. Excuse me, the product rule, whereas the other one we're going to use the quotient rule. So if you look at example 7, since we have a plus sign and they both have the same log bases, it means it's the product rule. It's like this. When you have the product rule, and you guys probably remember it, but maybe you don't, but you should. The product rule is this. If I take x to the 3 times x to the 5, I don't get x to the 15, I get x to the 8. You add them, right? Everybody agree with that?
It's 5 plus 3.
Yeah, that's exactly. Now, using that same rule for logs, we can change this thing into exponential form. But first, we have to use the quotient or product rule. In this case, since it's a plus, we have to use the product rule. So you keep the base the same, log base 2. Look at this line right. The second line right here. The log stays the same, but look at the top parts. You multiply them. You take the x times the x minus 7 equals 3. Now it shows addition here, but that's what I just got through showing you with the x's. But in the log, once you have the addition part, you multiply them. So you have x times x minus 7. The other side is still 3. Now, you switch the x and the x minus 7 to the right, put the 2 to the 3rd power, and you can drop the log. So now you have 2 to the 3rd power, which is 8, equals x squared minus 7x. You set it equals 0. You have x squared minus 7x minus 8, and you factor it. It becomes x minus 8 times x plus 1. Why? Because the 8 and the 1 have to equal negative 8, and we add the 2 middle terms, the negative 8 and the positive 1, it gets to be negative 7. Now, what are the 2 numbers that do that? 8 and negative 1. Now, if you put 8 and negative 1 into the original equation, what's 8 minus 7? It's 1. What's 8? It's 8. Now, if you put minus 1 in there, it becomes a negative log, and you cannot have a 0 or negative log, so the answer, negative 1, is no bueno. The only answer is 8. I don't know if they tell you that somewhere, but it should say the only answer is 8, and it should tell you why. I don't know if it does.
It just said the solution set is 8 underneath the check.
Yeah, but it doesn't tell you why the 0, why the negative 1. It should say you cannot have a negative or a 0 log. And it just doesn't reinforce it. But you're right. It's true. It tells you the answer. But I want people to know why. It can't be negative. Now, the number can be negative. Now, look, you got answer of x negative 1. If you had this, just wanted to let you see here. If you have an exponent that says for a log base, and your x is a negative 1, it works because then you have log quattro. Because you put this into the air, 5 minus 1 is 4. So in this case, it's a yes. But in the other case, it wasn't because you just had log to the x. And the negative 1 plugged into that means it's a negative. It's no good. Now, last question I promised you. Next page. I want to do number 9 because this is pretty good. And see, they're probably, geez, I think there's some finance questions here, but maybe not. So anyway, you have the equation for blood alcohol that the Texas Department of Transportation and the police all use. That is R equals 6 to the Euler to the 12.77x. Now, what does that mean? Blood concentration level is R. And they say, let the R be 17%. Now, what does that mean? It means that if you have a certain amount of alcohol in your blood, that you have almost a 1 in 5 chance of having a wreck. That's a fact. The statistics don't lie. A lot of people will say, I'm not drunk, I can drive. Their alcohol level is greater than 0.08, and boom. But officer, I can drive. Right. You drove into the telephone pole, but it was moving. No, it wasn't moving. You were moving. All right. So anyway, and you guys all know the second strongest lobby in the United States. Does anybody know what that is? There's only one more powerful. There are a lot of lobbies in the United States, but this is the second most powerful. Any clues out there? That when these ladies come into your office and you're a congressman or senator, you automatically say, yes, I agree. And that's MAD, Mothers Against Drunk Drivers. If you've if you run into a mother who lost a son or daughter because of somebody being drunk, let me tell you, they will never forget. There's only one group that's stronger and more powerful, and they hit Dallas Bus Department. You guys know what that organization was? Because by the end of the day, I don't know how many people were fired. Do you guys know what happened? Not too long ago. It's the PBA. They are the most powerful lobby, period. They are Paralyzed Veterans of America. And this one guy wanted to ride a bus in the city of Dallas, and it passed him every day because it didn't have wheelchair accessibility. So he stopped the bus driver, him and his buddies. There were like 5 of them, maybe 7 of them, sitting there, and he wanted to get on the bus. And the bus driver says, I don't have a wheelchair access for you. I can't take you. He says, well, then you help me on the bus and fold my chair. Now, anytime you do something any day nowadays, it's all recorded. You might as well just, if you don't, you're taking stupid pills if you don't think that things are being recorded. The driver said no. Somebody pulled out their phone, started videoing it. The guy in the wheelchair chains himself to the bumper of the bus. Now, he's telling the bus driver, if he doesn't get a ride, he's not going anywhere. The bus driver says, no, if you chain yourself to the bus, you're going to have a bumpy ride. And of course, the bus driver took off and the wheelchair guy went flying. And by the end of the day, every lawyer in town was soliciting wheelchair veterans to be their customer. Needless to say, Dallas DART has put those wheelchair accessible lifts on most of their buses. So anyway, I got off on the wrong problem there. But anyway, so now you have R equals C 6E. This is a formula, 12.77x. R stands for the percent of blood in your system, and X is the blood concentration level. This is the formula. So if you look at it, wherever there are, the other thing about the book, and I don't know why the book does this, they start out with the formula R on the left, and then they switch it. Now R is on the right. I mean, they should just keep working on. I guess they want the X on the left-hand side. So the second line is the same as the first line, except for R is on the right, and it's 17%. Now, from this line forward, you guys know how to do this. You're trying to get X by itself. So you divide both sides by 6. Now you have e to the 12.77x. You take ln on both sides. They cancel. And the 12.77x becomes the left-hand side because the ln and the e cancel, like so I have saying 10 over 10, like we talked about, and the 12.77, the power rule comes up front. But if you use ln on the left, you have to use it on the right. Then you're going to divide that ln 17.6 by 12.77. You can concentrate and study on this, and you get the blood alcohol level of 0.08, which in Texas is, by the way, illegal. Let me put in ln 17 over 6 in parentheses over 12.77 and see if we get 0.08. Let me do that. So here we have our calculator, and it's not sleeping anymore. I'm going to put in my parentheses first, then I'm going to put in my ln, 17 divided by 6. Now, I have to do the parentheses first for this calculator. 17 divided by 6. Close parentheses twice because I have 2 opens, I have to have 2 closed. Divided by 12.77. And if we've done it right, it will say that if you have a blood content level or concentration level of alcohol in your system at the 0.8 level, that you have a 17% chance of a wreck. Let's see. It's a little greater than 0.8. It's 0.081. Nonetheless, you go to jail, and in Texas, the rules have changed quite a bit. You can't get out of it anymore. It's tough. It's really tough. All right, you guys, this was a lot of stuff tonight. Are there any questions about this? Or let me take attendance while you might be thinking of questions. Make sure I have everybody correct, because I think folks that usually come in that I didn't get credit for is like Erica Whitehead. Is Erica in here now?
Yes, I'm here.
Okay, good. Let's see. Gabriel, are you here, Mulvaney? No, Gabriel. Is there anybody here that I don't have that didn't get their name called? Let me do it this way then. Melissa Flores, are you here? No, Melissa Flores. Alma Garcia, did you make it? No, Alma Garcia.
I'm here if you didn't get me.
Who's that?
This is Emma.
Let's see if I got you. I didn't get you. Okay, that's good. Let me see who else I do not have. I got the Gillises, didn't hear. Jordan Guerrera. Oh, Gordon? Jordan, rather. Lillian Holmes Hancock. She usually is here. Make a note of that. Let's see who else. Over on that page. Dylan, are you here? No, Dylan. Vinicio. Vinicio. I have everybody else accounted for. Any questions of me? Kind of a long night. All right. You're a good group. I'm going to have to try to do your report card. I hope you have a good night, and I'll say good night then.
Thank you. Have a good night.
Good night, everybody.
Good night.
I'm going to just sign out and hasta la vista.
Good night.
Thank you. Very good night.
Good night, Sharon, Indira. Good night, everybody.
Good night.
Good night.
Good night, Rebecca, Rosio,